Hello everyone, I'm a Kaggle Grandmaster in NVIDIA. My name is Chris Deotte. I'd like to share with you this cool idea called stacking, which helped me win first place in Kaggle's recent playground competition. Normally when you train a model, you input a bunch of features and the model learns to predict the target. With stacking, first you train a whole bunch of level 1 models. And then you train a level 2 model, which as input takes all of the outputted predictions of the level 1 model and then learns to predict the target. The way you make an accurate stack is you have to train a large, diverse selection of level 1 model. So the secret is speed and experimentation. The fastest way to train models is using GPU. If we train gradient boosted decision trees, there's a parameter which lets us turn on the GPU. If we're training deep learning neural networks, most frameworks will use the GPU. And if we're training statistical machine learning models, we can use NVIDIA cuML, which will accelerate the training on GPU. So in addition to training a whole bunch of different types of models, we can also add diversity by changing the pre-processing and changing the feature engineering and changing the hyperparameters and the architecture. Another way to make diverse models is to solve the problem in new, unconventional ways. In this competition, we had to predict how long a user would watch a podcast. The most important feature was how long is each episode. Here we have a scatter plot showing a strong linear relationship between episode length minutes and listening time minutes. In general, people watch about 72% of each episode. So instead of predicting the original target of minutes, we can predict this ratio. So we replace the original target column by the old target column divided by episode length minutes. Another way to solve this problem is to predict the residual. The black line in this picture is a linear regression model fit on the scatter plot. So instead of predicting the original target, we can predict the original target subtracted by the predictions of a linear regression model called the residuals. So using these three alternative techniques and training as many models as fast as we can on GPU and using different pre-processing and different feature engineering, we can make a huge variety of diverse level 1 models. And this will allow us to make the most accurate stack possible, which won first place in Kaggle's recent playground competition. To learn more about my solution and how you can use NVIDIA cuML to accelerate the training of your machine learning models, see the links below.